everyone. Good morning. The subject name compiler design. Previously, we discussed about some of the concepts which are related to the code optimization. Now, in this lecture, we are going to discuss about a brief overview of what are the basic blocks and flow graphs in the code optimization phase. What are the flow graph and basic block activities in place of this code optimization phase of the compiler design. This is the one of the important phase of the compiler design. Now, we know that in several programming languages, we are going to implement a block of statements to be put inside a curly brace, for example, in C programming language. So, such block of sequence of statements, that is the program control flow, will go from one to another with statement by statement. Whenever the statements, the control reach to the corresponding block, automatically the control enters into that block and starts the procedure of activations for that functions. Okay, so we are going to verify these statements inside the block, and the compiler also here the statement by statement checking. That means whenever suppose in that particular programming language it is using another programming language may use a different type of notation begin and end. So in each of these invocations at this time of the control enters to this begin, the activations takes place. And at the end the completion, that is the control is of block of statement is completed. That means it is not a programmatic program and it is a different end. It is a end which is different from the program end. Total program end is different, and this control flow block of statements end is to be different. So like this, a block of statements, that is sequence of here block of sequence of consecutive statements in which a flow of control enters at the beginning and leaves at the end without any halt or possibility of branching except at the end. Now we are going to see with an example. Now in this example, so a sequence of 3 address code notation can be represented within the block, each statement. So here T1 equal to A star A, that is one 3 address statement to be represented inside the block, and T2 equal to A star B, T3 equal to 2 star T2, T4 equal to T1 plus T3, T5 equal to B star B, T6 equal to T4 plus T5. A 3 address statement x equal to y plus z, it is said to define x and to use the reference y and z. Now a 3 address statement x equal to y plus z, we are say that it is a defining, we are going to define that x, and what are the y z, it is the reference which is used in that 3 address statement. Now there is an algorithm which is used to partition the sequence of 3 address statements into basic blocks. We have seen previously a set of consecutive statements as a 3 address statement notation. Now we are going to apply an algorithm. This algorithm works the division of various statements as separated into division of blocks. That means a block, we know that a block contains a sequence of statements. So like that, as many number of blocks you can put some series of statements, and then the control will be entered into that particular block, and series of statements are executed and then completes and by end the completion of the, that is leaving of this control. Like that, once again another block enters the control enters the other block, that is statements, Another block, list of statements, block, list of, like that as well. So this is block 1, block 2, block 3. Like this, we are going to write several number of blocks is to be implemented. Here the particular control enters into this block and complete this one. After this completion of this first block, then second block enters control, sequence of statements execution, the control leaves. After second, the control enters into third and the sequence of statements and completion of the this third block, and then this takes place. Here the algorithm, name of the algorithm is partitioned into several basic blocks. Series of, say for example, 10 statements, 100 statements are there. By applying this algorithm, we are going to divide some series of steps into one block, another series of, like that as per the record. So first to see the what is the input that is to be given to this algorithm means a set of statements, that is 3 items. So previous example we have seen T1 equal to A star J, 1 3 statement, T2 equal to T3 equal to T4 equal to T5 equal to T6. So these are all 3 address statements. These 3 address statements can be given as an input to this algorithm. That means in that may be any number of statements which can be given as input. And what is the output which you are going applying this algorithm? By applying this algorithm, what output you are going to get? So here in this case, it is the list of basic blocks where each 3 address statements are represented in exactly one block. These 3 address statements are represented exactly in one block. So each of the 3 address statements can be represented exactly in one block. So that is the output scenario. Now what is the method that is to be applied while working with this algorithm? What mechanism it is, taking the input and doing the part and then giving the result. So based on what conditions, means here the applying algorithm is procedure. The first one is we have to define a leader, set of leaders. It is called as set of leaders. The first foremost important thing is determine the leaders. That means the main components. The first statements of basic blocks, that is called as first statement, and this is first statement we are considering it is a leader, and any statement which is imposed for that conditional or target to this particular statement, that is unconditional go to, is also a leader, and any statement which immediately following a go to or conditional go to, it is also a leader. And such type of things where the occurrence chosen the leader. Here the first statement, set of leaders to be identified. How the leaders are this one? So the leaders may be used for the purpose of identifying the basic block main procedures. So that's why what are the nomenclature that is to be implemented with this one is the first statement. Whenever if you see in the list of statement, the first statement, foremost statement, that is to be considered as a leader. And another one is any statement that is to be that is the statement to be applied as that is target or which contains conditional or unconditional go to. Those type of statements are considered as a leader. And another one is any statement which immediately following go to or conditional go to also can be considered as a leader. Now here for each leader, it is a basic block. What is a leader? Here each leader we are going to consider it as a block of consists of statements. So this is one leader which contains a block of statements. And all the statements up to not including the next leader. So next leader are end of the program. Some of the other statements which are there, which are not comes under this. That means conditional or unconditional, which are not there. Suppose if that is available in that one, you can consider as a separate leader, one more leader, which and then process the list of statements and again any other further notice occurs for the presence of a leader, you can include as separate one more leader. Like that you can keep on inserting several set of leaders. Uh, but and this it is a called as a basic block which consists of the leader and all the statements up to, that is not including the next leader, are end of the program. End of the program. We are going to make a several set of statements. The statements are called as three-address statements. And the main aim is we are going to give certain set of three-address statements. So here the main concept is leaders. So for example, how the algorithm works out with this an example, we are going to consider the following source code, which is consists of computing the dot product of two vectors with a and b of length 20. Here dot product of vectors of a and b length 20. Here the first one is the procedure, the source code procedure is like this. And for this procedure, we are going to implement a three-address code notation. The algorithmic steps as a left-hand side. For this algorithm side of left-hand side, the right-hand side 300 code to be generated for each of the steps. So here, if you are going to compute a three-address statements, product is equal to 0, we have written as a first statement, and I equal to 1, which is given as a second statement. So here the third statement, that is compute T1 and T2. Now A of T1 is to be computed. A of T1. Suppose here A of I is given, but if you consider T1 I as T1, that is A of T1 is to be computed. Now what is the index here? T1. So now what is the value of this T1 that is to be computed? So that is to be considered as some 4 star I. So that's why here the third step and fourth step. The T1 is computation and A of T1 is computation. These two are belongs to this T1, T3, T1 and T2. Now if you consider T3 and T4, so B of I, this is the index B of I where I is to be processed as here some T3. So I is to be processed T3. Now the index is to be calculated with this two set of one set of statement, that is three-address statement T3 equal to 4 star I and T4 equal to B of T3. So both A and B are to be processed now. Then the result is stored in stored in T2, and in this result is stored in T4. Now we are going to apply the this product, that multiplication for both the cases. This multiplication star, as previously what individually we have computed as a separate three-address statement, index as T1 and T2 as A of T1, that is result is to be stored assigned to the T2, and in the second B index is stored as T3, and the array of B, that is B of T3, that is to be calculated and the result is stored in T4. Now we performed the star operation of both the array values, that is T2 and T4. We are getting some result, that is T5. So this is the actual result of the statement which is to be performing the multiplication. Now next step is we have to apply the plus operation. The prod plus this T4. Now here T5, what we are getting, that is T5. So we are going to write this as a product plus T5. Now T5 that is to be as 8th step. That is to be considered as 8th step. Now the result is to be assigned. Now we are going to get the result in T6. Final result is in T6. That is to be assigned as this product, final product. So that's why this final product is to be written as a ninth step. Now we perform next after getting this result, we have to give an increment operation, that is T7 equal to I plus 1. Now that increment I plus 1 result is to be stored in T7 and assigned to I equal to T7. So these two steps are to be implemented for 3-address code notation for the step I equal to I plus 1. Now the final while condition, if that is while I less than or equal to 20, this is to be processed with this I less than or equal to 70, go to 3. That means go to 3 means here once again you perform the checking the condition here, I condition checking, and while checking the condition we apply the go to statement. So based on the condition true, it will go to 3. So if not condition exists, then it won't go to the third statement. It will comes to the completion of while loop, end of the while loop, and it exists. So here in this one, what is the basic block 1 and 2? So we are going to consider some set of statements as base. So here product is 0, I equal to 1. These two are to be considered as one header. And 3 to 12, these three statements to be considered as one header. So this header 1, header set of headers you can form from this algorithm. So this is a separate header, second header, first header, header 2. Like this we can apply this algorithm and we can make use of this statement. So here we are identified some leaders, that is where the presence of this block of statements has 3-address code notation, and this algorithm applied of this sequence of statements by determining several leaders, and the output that is to be generated is several list of basic blocks, and these blocks consist of 3-address statements which has exactly one block, Now, flow graphs are to be implemented with this set of 3-address statements, that is as a part of this basic block notations. Now, we know that a flow graph consists of, it is a graph, and the information is to be represented inside the flow graph with the help of these basic blocks to make up a program. Several nodes are to be present in that flow graph. We know that nodes are, that is circles, and this consider as one basic block of statements, and it also contains a starting or root node or initial node. Now if we consider this example, B1 is a basic block, B2 is another basic block. Now in this example we have seen the product is 0, I equal to 1. So we are going to make these two statements as a header 1, and the remaining statements 3 to 12 we are going to put another header, that is a block 2. Here this is one header which is called as block 1, and we are going to write another header block 2, and this block 2 which has to be written with the third 4 star I of T1, 4 star I, B of T3, T2 star prod plus T6, I equal to I plus T7 equal to I plus 1, I equal to T7, Y 5 less than equal to 20. But now these steps, each of the steps same to be included in this block. And after that means here go to B2 means if the condition is true, then the self loop is to be drawn to indicate that for repetition of all the statements with the whenever the I value condition is checked and go to B2. That means the block of statements is repeated. So here this consider as B1 is the first node, that is also called as initial node, starting node of the program. Whichever the header that is coming at the beginning of the program, the first block, then that is called as initial node, that is header 1. and the next header that followed by this node, followed by this block, is another block that is called as B2, and we are going to give a connection. That is, connection means here there we are called as edge or transition. Edge or transition, that means we are going to write a label that is not label, that is arrow direct arrow indicating that there is an edge or transition from block B1 to B2. That means whenever the control enters into this block initial node, and the statements are to be represented as a three address statement or to be executed successfully, and after completion of these two statements, control leaves. Here control leaves, then it goes through the next header to this transition, to this block of statements B2. And the last statement in the B2, here we go to B2, is the first statement B2. Why? Because the list of statements enter into the control flow one by one executed, and finally if I less than equal to condition satisfied, then it immediately jumps to the first statement of B2. The target of jump from the last statement of B1 is the first statement, and B2, so there is an edge from B1 to B2. So B1 last statement, B2 first statement. So that is the edge to be drawn from this one. Last statement of this B1, which is written, which is given with a one box representation, and another one with box representation B2. Now, if I write a B1 with one block of statements, a transition, and B2 with another block of statement, then here we are considered as a B1 is a predecessor. Why? Because it is the starting initial node, and whichever is the following, then that node is called as successor node. The nodes are called as, these are called as these blocks. This is one node, block B1, this is another node. These nodes are is to be represented in the flow graph. Then node block 2 with another node. Like that, several nodes are there in the flow graph, and the transitions are represented edges from, there is a connection from block 1 to block 2. That is, the last statement of B1 get connected with the first statement of B2. So in this way, the graphs are to be determined with the set of header pointers that is to be determined with, that is called as especially nodes, and nodes are to be considered inside there's the basic blocks of the program, and these nodes are to be traversed each and every till the program ends. And the first and foremost block of node, that is statement, is to be considered as initial node and predecessor. Now sometimes we are going to see the loops inside these procedures. So here we observe that there is a loop. What is the loop here? The block B2 is loop, contains loop, whereas B1 doesn't have loop, whereas B2 contains loop. How do you know the loop? How do you verify that graph representation? How do you verify whether it contains? Means here there is a arrow mark which points to the edge. There is an edge which starts from this last statement, can be given back to the first statement of this one. There is an edge which is labeled, which is drawn from the last statement of that B2 to the connecting to the same first statement of that same block. Then we can say that there is a loop occur. So now we understand that block B2 contains a loop. So B1 doesn't contain loop. So what is the loop means? Here the nodes, all the nodes in the collections are strongly connected. In the here inside this one there will be several nodes. All these nodes are strongly connected, and these nodes are to be available as unique queue entries. These nodes are unique queue entries, and the no other loops is called as, suppose a loop is to block B2 contains a loop, block B2 contains a loop, then if that loop contains any other loops, sometimes you are going to write a loop inside other loop also. So if it contains a loop, then this loop contains any other loops, then that is called as inner loops. Then that is called as inner loop. This inner loop doesn't contain any other further loops, so it is the innermost loop. And outer B2 it contains a loop. So what is the loop called statements? Which is the loop of statement which is the repeated, but it does not contain inside another loop. So that is to be considered as a loop structure, because the repetition of three address statements are to be continuously executed the control, and then leaves whenever the condition not satisfied by this one. And another important one is the transformations on basic blocks. Here the number of transformations can be applied to basic blocks without a set of expression computed by this block. But several blocks are to be implemented. So out of that you can apply any transformations also. What are the transformation types are available means, we know that previously we discussed about structure preserving transformations, and another one is algebraic transformations also. So in structure preserving transformation there will be several categories. One is common sub-expression elimination, another one is dead code elimination, and renaming of temporary variables, and fourth one is interchange of two independent adjacent statements. So previously we have taken how the common sub-expression eliminated, we have taken with an example also. Now we will review the small brief of this common sub-expression elimination. Now the statement A equal to B plus C, it is one three address statement. B equal to A minus D, some three address statement. C equal to B plus C, D equal to A. Now we are going to observe that this computation B plus C, which is same as this computation, and the computation A minus D same as A minus D computation. That means this computation and this computation, the same we are performing. That means suppose if the variables A, B, C, D are there, then we are going to performing B plus C at one time and A minus D another time, first time, second time, and this first is assigned to A, and the second time we are performing, take one more assigning to B. But B plus C, C also assigning computing the same, D also computing with the same. That means A minus D, A or B plus C. So repetition of the computation. So this type of computing the same expression twice and thrice or several times instead of computing. So we are going to replace what, instead of computing C once again, A already contains some result. So instead of computing one more time, we are going to assign C equal to A. Why? Because A already having the result. Similarly for D, which is to be once again computed with A, in order to perform A minus D, already this computation is available and the result is stored in B. So that's why we are going to assign the value of B with D, and this avoiding this computation repeated second time executing the same computation. And we are going to write this as a separate notation. So basic block as A equal to B plus C, B equal to A minus D, and the computation is avoided. We are going to assign C equal to A, and the computation avoided, and we are going to write D equal to B. Now this is called as a common sub-expression elimination. That means if any expression is to be a repeated way of executing, we are going to find out that one and eliminate commonality in between them, and you can give an equivalent block of equivalent set of statement so that the transformation is preserved. So that's why it is called as structural preserving transformation. The result may not be affected even if you avoid the computation of b plus c and a minus t. And another one is dead code eliminations. We have seen renaming of temporary variables also we have seen. That means here dead code eliminations, some of the variables which we are entered into this program, and these are not removed. We are not removed this type of variable. So that means these variables are present available but not used. It is available in the program and not. Suppose large number of the amount of this type of these dead variables are available, then these procedures while constructing may be chance of giving a reference to this already existing or not or dead variables also give some with the same name already exist with that within the procedure which is already running. Then there is a deviation occurs resolving these conflicts. So that's why it is better to avoid or remove the which are not used by long duration of the program situation, and for that variables identify, and this has no meaning even if we kept inside the program also. Then such variables are to be monitored carefully, and by applying garbage collection methods or any other useful techniques, and eliminately if you do this then we are going to perform this code optimization whenever we apply this dead code eliminations. Whenever we apply the process step dead code elimination, automatically we get the performance of the application so that we achieve the task. Another important one is this is renaming of temporary variables. That means that's what here the variables are available but may not be used. For example, here t equal to b plus c. Here t is a temporary name, and sometimes you may change this assignment to u equal to b. That means u equal to b plus c. That means a temporary name t which is changed to another temporary name, and we are going to use that u several ways, and the value of this basic block doesn't change, then the transformation equivalent to each statement defines a temporary names, a new temporary called a normal forms. So like this, we are going to giving a new name to the existing temporary with another statement, another temporary name, so that we achieve some of the tasks. Like that is available in the basic block that is transformed into a equivalent block in which each statement that defines a temporary, and this leads to another solution, normal form block. And the interchanging of the two statements, that means for example temporary t1 equal to b plus c, another temporary t equal to x plus y. So these two are interchanged, then basic value of t1 is doesn't affect the t. So any modification occurs, the result is not changed, then we are going to give this interchanging of the statements. Verify the um, result that is does not affect with the both the statements. So in that cases we are going to reach a reordering the construction of the structure. Reordering the structures are both swapping or interchanging of that particular block of statements, and then the final result may not be affected, so that this can affect the smoothness of the program. And another one is algebraic transformation. We already know, we discussed about this type of algebraic transformations with the example also. Same here, the x equal to x plus 0, x equal to x star 1. x equal to y star 2. So instead this plus operation, so x equal to x plus 1. Here star is a more consumption operator performing than plus. So the result is x only, x equal to x. But if you perform plus operation or if you perform star operation with 1, the result is same. So we are going to avoid this operation. Why? Because it is equivalent, algebraically equivalent set of the thing. So expensive operation is here, power is the expensive operation, y power 2. So y power 2 is an expensive operation compared to multiplication y star y. So here star is a multiplication operation. So that's why this is to be avoided. This is to be avoided, and this is to be used where this availability is there. You can replace with this the power with the multiplication. Where multiplication is available, you can so expensive operations are to be eliminated with the lower ones, and this usage of lower ones, which gives the same result as the expensive operation. So the result may not be affected. But here the optimization of the code takes place, and we can get the results very easily. So this is the um, concept which is related to this basic blocks and flow graphs. And in the next, we are going to give a brief overview of next new topic. Thank you, all of you. All the contents which are available from this book, that is Compiler's Principles. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.